grade 3/4s. I wish I could see you again, but it's nice that you've tuned in again today. I have really enjoyed hearing from so many of you this week about your balloon rockets that you've been making and your ideas for experiments around that. In particular, I would like to mention Lucy in grade 3/4, who did this fantastic experiment that I did not think of at all. She made a balloon rocket that went from low down to up to her basketball ring to see if balloon rockets will go upwards as well as sideways. I just thought this was a brilliant idea because she took the ideas I had, she didn't use any of them, she came up with her own, and then she sent me a video of how that worked. It was really great, so well done, Lucy. Now, since I made the video at the start of this, I've actually just had a whole bunch of your projects come in. I've been reading them, and there's a whole heap of other kids other than Lucy that also did great experiments with their balloon rockets. So I thought I'd just mention a few of the great ideas that I read today. I've written them down so I can remember them all. There was one student who tried looking at the number of breaths you blow into a balloon and how far that makes the rocket go. Great idea. There were two other kids who came up with the idea of the balloon rocket going up, which I was really impressed by because I never even thought of that before. There's someone else who looked at changing the direction of the balloon and putting it on sideways instead of the way of the string to see what would happen, and it went spinning around the rope, which is great. Someone else tried adding weights to their rocket. Someone put water inside it to see what would happen, and someone else tried smooth versus rough string, which I always also thought was a really good idea. So 3/4s, you have outdone yourselves. I got so many responses. It's really great to hear that you're all having a try. Hopefully you'll have a go at today's experiment as well. See you later. Hey Abby.
Hey.
What are you doing?
Homework.
Well, you can't do homework anymore because this is when I interrupt you. I'm sure you'll be a good sport about it.
Yep, sure.
Because we need to play a game of, is this funny to a teenager?
Sounds good.
Now, I sort of half explained this to Abby, but maybe she doesn't fully understand the rules, so I'm going to just explain the rules, and then you can do your homework later, after we've had a bit of a laugh.
Sure.
So how this works is, I have found a bunch of science cartoons, and I've saved them on the iPad, and I'm going to show Abby the science cartoons one by one, and we're going to watch her reaction. Now, if she thinks it's funny, like I think it's funny, then you get to see it. But if Abby decides it's not funny, then you will never see it. You'll never know what it was that I thought was funny that Abby didn't think was funny. You'll never find out. So it's a bit of a mystery. Now, to show us...
My opinion changes everything.
Does it? Yeah, it does. Even if I think it's hilarious. The worst is if I'm cacking myself laughing and you don't think it's funny at all.
Yeah, that would be embarrassing.
Embarrassing for me. Okay, so these are your options, Abby. This joke is hilarious. Ha ha ha. Teary eyes, crying. If you start crying with laughter, that's the one you've got to pick. This one, joke's good, but not hilarious. That's this one. Have you had a good look?
Yep.
Yeah, that one. Now this one's like, not really funny, Mum. I don't love that one.
Yeah.
That's the, not, yeah,
Yeah.
half there. This one is like, oh, why would you ever embarrass me by showing me this joke on the camera where everyone's watching? Okay?
Yeah, either that or I don't get the joke.
Or you don't get it. Oh, I've got no idea what we're talking about. Okay.
Alright.
So, Abby, are you ready?
Yeah.
I've got the first one. This made me laugh even just before when I pulled it over. Okay, ready?
Alright, I'm ready.
So I'm going to show Abby the joke. You're not going to get to see it unless she laughs. So, straight face. Let's start. Okay, we're going to start like this.
I don't have a straight face.
It starts like this.
What are you doing?
Okay, you ready?
Oh, that's so bad.
I win. Come on, which one, Abby? I'm pretty sure we can all see which expression you've got on your face right now. What's your thinking music? Thinking music time. Quick,
Okay, I'm
pick.
thinking this one.
Wait, it was hilarious. Oh, but it's still, you get to see it because it's not a sad face.
Yeah.
Is that fair enough? They
Yeah.
see it if it's those two.
Yeah.
Okay, so I'll show you. Today you're going to be drawing what's called a force diagram. This is what scientists draw to show which forces are acting on objects. So here I'm just drawing a table with a ball on it. And then I'm going to be drawing arrows to show forces acting on it. So here you can see a force that is pulling the ball down onto the table. And then I have another arrow pushing up, and this is a force pushing the ball up, which is from the table. So scientists use arrows to represent forces. Sometimes they use a big arrow to represent a big force, and then a little arrow to represent a small force. Okay, hello grade 3-4s. Today we're going to start talking about gravity, and that's going to lead on for the next couple of weeks. And there's already been a little bit of an introduction that you've watched, but I just want to show you this. This is my world. You've got to pretend this basketball is the Earth. And on the Earth there are 4 people standing. You might recognize some of them from LegoLand. We have Danielle, she's holding a radio. We have scary motorbike dude with a cup. And I just realised one of his arms is backwards. And then we have Sunny over here with some binoculars. And then we have old man with his hairbrush. So these 4 characters are standing on the Earth, and they're all holding something in their hand. Now, what I want you to do is, with the information that I just gave you in the last video about force diagrams, is I want you to draw a picture of this ball, just a circle, and I want you to draw 4 little stick figures around the outside of that. Then in your head, I want you to think, all right, if each of these 4 people were to drop the item in their hand, if this was the real world and they were real people, where would those items fall? So if you think they would fall down, you do down arrows. If you think they would go this way, you draw up arrows. If you think they'd go that way or that way, you do sideways arrows. And you might even think you want the arrows in different directions for each person. That's okay too. But this week, I want you to draw that picture and write down where do you think those objects would fall to. And then next week, I'm going to show you the answer to that question. So this is what I'd like you to do in your science journal this week, please. Write a heading that says gravity, and then I want you to draw a picture of the Earth, or just a circle shape, with 4 stick figures standing around the outside. Now in each stick figure's hand, you put a little ball, and then you draw the arrows next to each person about which way their ball will fall if they drop it. Hello 3-4s. For the experiment that you're going to try today, you need to try and find 2 objects in your house that are the same size and the same shape, but they weigh different amounts. Now this could be hard. You might be spending a fair while looking for something, but I'm sure you can. So I'll give you an example of what I found in my house. I have this giant marble here, and I have this polystyrene ball. I know they're not exactly the same. If you can get exactly the same, that's better, but they're pretty close. They're both spheres. This one's really heavy, this one's really light, so you could use these. And the other thing I have, but I got this from school, from a special science kit, so you might not be able to find this, but I found a kit that had blocks all the same size and shape, but different weights. So this is balsa wood, and it's really light, and this one is copper, and it's really quite heavy. So I'm actually going to use these 2 cubes today for the experiment, because I'm worried the balls might roll off and fall in the garden and I'll never see them again. So I have a question for you today. It's about gravity, and next week we'll answer it. But my question is this: do heavier objects fall faster than light objects? The question's going to be on Google Classroom, so once you find out the answer, I'd like you to put it up on Google Classroom so we can all see what you found out. Okay, so the way we're going to do this experiment today is you have to have your 2 objects sitting on top of a table or a bench or something solid, and on the ground you're going to have something soft that they can land on, because you don't want them to, you know, make a hole in the ground of your floor of your kitchen or something like that. So you need to put the 2 objects, the one heavy one and the light one, right on the edge together, and we want both of them to fall off the table at the same time. So if I was going to do this with my hands and drop them, sometimes I might accidentally let go of one before the other, and then it's not really a fair test, is it? Because we need everything to be kept the same except for the weight of the blocks or the objects. So here I have my wooden one, here I have my copper one. They're lined up pretty well, so when they fall they should land on this blanket. And the trick is, I think, to use a stick or a ruler or something like that and to bring it behind them and have them come at the same time towards the edge. Now, as you do this experiment, this is a little bit tricky, but I want you to try and film it in slow motion on your iPad. So get your iPad out, and when you open the camera, you've got a choice of camera, video, and then there's one that says slow-mo, and I'm pretty sure you can film things in slow motion. So when you do this, it means you can watch it back afterwards, and you can tell a bit easier which one hits the ground first. So I'm going to just try this now, film it on here, and see if I can slow it down afterwards, see which one fell first. But I might not show you what happened. Alright, here we go. So once you've done it and you've got your objects on the ground, go back, watch your video in slow motion and tell me, does a heavier object fall faster than a lighter object? That's my question for you. Alright, see ya. You might know this already, but in science, when you do a test, you should always do it more than once. If you do a test once, there might be something that happens that normally doesn't happen. And so what scientists like to do is to do the same test lots of times over and over. I reckon you should at least do this 3 times and record it every time just to double check. If you want to do it 10 times or 100 times, go for it, that's up to you. I just did it once today just to show you how to do it. Why don't you go try it a whole bunch of times and see if you get the same answer every time. Now when you do this experiment, you might actually in your head have an idea of what you think is going to happen. But in science, it's really important that you try and switch off those ideas and just think, I don't know, do heavier objects fall faster than light ones? Or do light ones fall faster than heavy ones? And pretend to yourself that you don't know the answer. And that will help you when you look at what happens to actually be able to see what the real answer is. Okay, good luck with that. I'll talk to you soon. Here I have a picture of a Pacific sea star. You can see that my drawing has improved dramatically in the last week. I think I spent 30 seconds instead of the 20 seconds I spent last week. So Pacific sea stars, they're actually not from Australia. They come from overseas in Japan, but they were introduced to Australia. Now we think that they probably got here in the bottom of ships and things like that. So I've drawn a beautiful picture here of a ship for you. And I don't know if you know this about ships, but when ships come, if we send a ship to Japan, for instance, with a whole bunch of boxes and birthday presents and important things like that, then that ship goes over there, drops all the cargo off, but it might not come back with the same amount of cargo. And ships have to have a really heavy base to them so they don't tip over or, you know, when the wind and the waves come. And so what they do to keep that ship heavy is they actually fill it up with water from the ocean at the port that they're staying at. It's called ballast water. So let's picture this ship went over there to Japan, dropped all its parcels off, birthday presents and all, filled up with some water in the bottom of the ship to make it heavy again, and then came back to Australia. This is exactly what happened. But inside that water that they collected from Japan, there were some Pacific sea stars. Now they might not have been the whole adult star or something, it could have just been like a baby or something like that. And the Pacific sea stars got into the Australian waters and just started eating shellfish, scallops, all the things that we didn't want to die, basically, that we try to grow. And because they're introduced, our species weren't used to them and they just got eaten up. Not good for our environment. So in the 90s, this pretty funny thing happened. Scientists and lots of people went out there and collected up as many starfish as they could from the ocean because they were going to kill them. But do you know what they did to kill them? This bit cracks me up. They got the starfish and they chopped them into pieces. And then they just threw them back into the ocean. If you know anything about starfish, you might know that starfish can regenerate or grow back from body parts if they're a bit of the central kind of part of the starfish is there, called the radial disc. And so when they threw all these little pieces of starfish back into the ocean, which was, a lovely thought, they ended up with millions more starfish than they'd had before. So it kind of didn't really work. And the reason I'm telling you about this is because science doesn't always get things right. And sometimes we do talk about this at school. Sometimes by making those mistakes, that's when you learn stuff. That's when you think, hold on, cutting starfish into pieces and tossing them back into the ocean isn't going to get rid of the starfish. In fact, it might increase the numbers. We need to think of something else. So I guess I've been kind of thinking, well, what else can you do? How do we get rid of the Pacific sea stars from our oceans now? Why don't you have a little bit of a think about that too? Last week on Science in LegoLand. "430 Whitehorse students radioed in to help Danielle and Sunny solve the mystery of the skull. These were some of the responses. Just as Danielle and Sunny were discussing which of the 430 students might be onto something, a giant creature scurried past. Both minifigures screamed, "Ah!" Following behind the creature came a very old man.
Sorry about that. That was just my pet rat. Ah, I see you found my old dead rat's skull. I keep it here as a reminder that all vertebrates have skulls.
Right, and that's not creepy at all. And with that, the mystery was solved. Did you guess the creature correctly?